everyone, this is a CMG tutorial for Project 2 of Dr. Balhoff's numeric simulation class. It is a 2D multi-phase black oil model with gravity and capillary pressure. So let's go into CMG. Let's press Start, All Programs, CMG, and the green icon called Launcher. When this comes up, we're going to click on Builder. Builder is the platform that CMG uses to build its files. Now we're going to click on the white blank page called New. This is going to allow us to create a new project. So CMG has 3 different simulators: GEM, IMX, and STARS. GEM is for compositional simulation, IMX is for black oil, and STARS is for thermal and polymer related projects. So we're going to press IMX. All the data are given in field units, so the working unit is going to be field. And now we're going to press OK and OK again. So this is the page that we'll be working with mostly. You can see in the model tree view, there's a lot of red X's, so hopefully by the end of this tutorial, we'll have a lot of green check marks. So we're going to start with a reservoir. If you click on the little triangle, another bar shows up, and we're going to click on Create Grid and Cartesian. So in the number of grid blocks, there's I direction, J direction, and K direction. CMG uses I direction for X, J direction for Y, and K direction for Z. So for our project, we have 80 blocks in the I direction, 75 blocks in the J direction, and only 1 in the K direction because this is a 2-dimensional project. Under block width, we have 80 blocks that are 75 feet long, and in the J direction we have 75 blocks that are 100 feet long. Now we're going to press OK, and a grid is going to pop up. We're going to populate this grid by using array properties. So on grid top, we're just going to give it a value of 1,000 even though we have varying depths. Under grid thickness, we're going to give it a value of 50. Under porosity, we're going to give it a value of 0.2, even though it's varying. And we're just going to give it a value of 100. And it's easier to fix those files when you go into the text files after you've created it. So we're going to give it just any value for right now, but we're going to go fix it in the text file later on. Permeability in the J direction is 0.15 of the permeability in the I direction. And we tell this to CMG by right-clicking on the box, clicking Edit Specification, and choosing the multiplication sign equals I times 0.15. And we're going to press OK. So this is telling you that permeability in the J direction is equal to I, permeability in the I direction, times 0.15. For permeability in the K direction, we know that it is equal to the permeability in the I direction. So we're going to right-click and choose the option equals I. And it's going to automatically set it to equal, and we're going to press OK. Next, we're going to determine which blocks are going to be considered null. So we're going to use the drop-down menu in the top. We can also scroll through it this way, but it's a little bit quicker if we do it using the drop-down menu. So I'm going to click on null blocks. I'm going to right-click and click on Edit Specifications. I'm going to click on Set Block to Null Where, and porosity is less than or equal to 0. And I'm going to press OK. So basically, blocks with porosity less than or equal to 0 are now going to be set to null. I'm going to press OK and OK again. Now I'm going to go into the rock compressibility section. Rock compressibility is 1e to the negative 6, and the reference pressure is going to be kept the same. So after all of this has been done, we have achieved a green check next to the reservoir. So we're done with the reservoir section, and we're now going to move on to the components section. So for the components section, we're going to click on Model, Launch Dialog to create black oil model. We're looking at a black oil case, so this is the one to use, and we're going to click OK. And we're going to specify reservoir temperature as 100 degrees Fahrenheit. We're going to generate data up to a maximum pressure of 5,300 psi. We're going to input our bubble point using value provided, which is 502.505. The oil density is 53 pounds per feet cubed. And for gas density, I'm going to input it using gas gravity, which is 0.6. And if you convert it back to gas density, you can see that this is the exact same value as the one that's given in the project statement. It's just easier to type in a gas gravity of 0.6. We're going to leave the reference pressure as is. And the pressure dependence of water viscosity is going to be 0 centipoise per psi. And salinity, we're going to keep it at 10,000 parts per million. And we're going to press OK. Now we're going to move into the PVT Region 1 tab. So under Generals, what we're going to do is basically check that what we've inputted is reflecting correctly in the General section, and correct some of the values that are different from what we're assuming in the project statement. So reservoir temperature is 100 degrees, oil density is 53, gas density is correct. We can check by looking at gas gravity, and it is 0.6. Water phase density is 62.4. Shrink this a little bit so it shows up. Okay. The compressibility of oil is 3e to the negative 6. And the viscosity dependence on pressure is 0.0001 centipoise per psi. The water formation volume factor is 1.01222988. Whoops. 98811. The compressibility of water is 2.87 e to the negative 6. The reference pressure for formation volume factor of water is 4,500 psi. The viscosity of water is 0.383. And the pressure dependence of viscosity is 0. And everything else looks good, so I'm going to click on Apply. Now we've moved into the PVT table tab. We were under the Generals tab, and after we click Apply, we were moved to the PVT table. Now we're going to deselect Include Oil Compressibility in PVT table, and we're going to click Apply and OK. So now we're done with the components section. Now we're going to move into the rock fluid section, which is very important for a multi-phase flow. So we're going to click on rock fluid types. We're going to click on the little triangle icon and select new rock type. We're going to select tools and generate tables using correlation. So we're going to input values for these tables using the data that was given to us in the project statement. The endpoint saturation for water was 0.2. The endpoint saturation for oil was 0.4. For gas, it was 0. KRO at connate water was 0.8. KRW at irreducible oil is 0.3. And for KRG at connate liquid, we're just going to give it a value of 0.8. And KROG at connate gas, we're just going to give it a value of 0.8. The exponents were all 2s. We're going to press apply and OK. So now our table is filled with values using those correlations. We're going to include capillary pressure and capillary pressure hysteresis. We're going to take a quick break from CMG and go to an Excel file that Dr. Balhoff posted on Canvas. It's called rock fluid empty. It's an Excel file. It has a list of all the saturations on column A. For column B, we have KRW. For column C, we have KROW. For column D, we have capillary pressure, and we have capillary pressure for imbibition in column E. The input values are over here, and all the equations are over here for both relative permeability and for capillary pressure. So in between the saturation of SWR and 1 minus SOR, which is 0.2 to 0.6 in this project, we can just fill out this Excel sheet by using the equations given here. I have already inputted the equations. So from 0.2 to 0.6, we're just going to use the equations that are given in the sidebar. And after 0.6, things start changing. So in order to better explain the importance of 1 minus SOR, which is equal to 0.6, we're going to look at an example, drainage and imbibition curve, and how it differs. So if you look at the drainage curve, you can see that the KRW extends from 0.2, or residual water saturation, all the way up to 1, as opposed to an imbibition case where it only ranges from SWR to 1 minus SOR. This difference in drainage and imbibition curve is caused by how a reservoir is charged with hydrocarbon. So initially, a reservoir is just an aquifer with 100% water saturation, and as hydrocarbon percolate into the reservoir, water saturation decreases, which is basically drainage cycle. When water saturation decreases, by definition, it is going through a drainage cycle. So in order to really fully capture the reservoir and its properties, we need to model both the drainage and the imbibition. So we need to extend our relative permeability curve for water beyond that of 1 minus SOR. And we do this by altering NW, which is the exponent that goes into KRW. And we can do this by using solver. I've already done the calculation, and the exponent is 1.7369555594. Whoops. And if you drag this, you can see that the value is very close to 1 at a saturation of 1. So I'm going to change it back to 1. And for the capillary pressure, we can use the exact same equation that we used previously and fill it all the way to a saturation of 1. And we can see that at that point, capillary pressure is 3.5, which is equivalent to the capillary entry pressure. So we can copy this and put it into the table that we were looking at. Now it is all filled. We just changed the water oil table. For the liquid gas table, we're going to leave it as it was defined by the correlations that we've used. Now we're going to go into the hysteresis modeling tab, and we're going to select model hysteresis effect in oil water capillary pressure, or J function. Select use drainage and keep the value as 0.1. Press apply and OK. And now you should have a green check mark next to rock fluids. So we're done with the rock fluids section, and we're going to move on to the initial conditions. Now we're going to go into the initial conditions. We're going to click on advanced. We're going to check block saturation at each grid block are the same as saturation prevailing at the block center. We're going to select water and oil with no free gas. We're going to move into PVT region parameter tab up at the top. We're going to give reference pressure and depth. The reference pressure is 4503.5, which is basically the pressure given at the water oil contact plus the entry pressure. And the depth is 74.45, which is the water oil contact, so we can use the same value for the water oil contact depth. And for bubble point, we're going to use a constant value of 502.505. Now I'm going to press apply and then OK. Now we're done with initial conditions. Now we're going to move on to numerical control. Since our MATLAB code is using a DT of 1, we're going to trick the simulator into taking 1 as its time step every time step. So we're going to change the maximum time step to 1 days, and the first time step after well change to 1, and the minimum to 0.99999, which is very close to 1. So I forgot to mention this earlier, but when we have a table, everything that's listed on the side, this is going to be the keyword to look for when you're looking for this term in the text format of the simulation file. So hopefully that will probably make a little more sense when I'm adding the heterogeneities in. So we're going to click apply and OK. Now we're going to move on to wells and recurrent. We're going to click on wells. And we're going to add all the wells. So for well 1, all the wells are actually a producer in the beginning. So well 1 is going to be the name. Type is going to be a producer. For constraints, we're going to define our constraints. Constraint definition. Constraint definition. Operate. And for well number 1, we're looking at a rate-based well initially, so stock tank liquid, and we're operating at 120 barrels per day. We're going to add another constraint, which is bottom hole pressure. We need to keep the bottom hole pressure above the bubble point. Now we're going to add a new well. So this is well 2. It's again a producer. We're going to define the constraints. Select operate, stock tank liquid, and it's 90. We're again going to add another of bottom hole pressure and 502.505. We're going to add another well, well 3. It's a producer. We're going to add the constraint. Add another well, well 4, another producer, constraint, constraint definition, operate. Add another well, well 5, it's again a producer. We're going to select a constraint, operate. Bottom hole pressure is the well constraint for well number 5 at the beginning. Same for well 6. And we're going to press OK. Now what we're going to do is we're going to add the second constraint that comes in at 500 days. So we're going to click on well, and we're going to click on the calendar that shows up at the top. We're going to find 500 days after since the simulation start, and you need to click somewhere around, or for some reason the date doesn't change, so click somewhere else. And now the date is shifted to May 16th, 1902, which is 500 days since the beginning of the simulation. So we're going to press OK, and we're going to go to the Constraints tab, add constraint definition, and for well 1, it starts as a rate well of 120 barrels per day, but after 500 days it changes to bottom wall pressure with a constraint of 502.505. So basically we just have to get rid of the first constraint. We can click auto apply, which will allow us to switch back and forth between wells without having to click apply all the time. So now we're going to go into well 2, add that same definition for the calendar, press OK, go to constraint, select constraint definition, get rid of the first definition, and for well number 3 we don't have any change in constraint, and for well number 4 we don't have any change in constraint. For well number 5 it changes from a producer to an injector. Unfortunately, CMG doesn't allow us to do that, so what we have to do is shut in well 5 and then create another well called well 5 injector at the same location. So we're going to shut it off. So we're going to add the date definition at 500 days. Okay, and this is different. We're going to go to options, status, and shut in. We're going to do the same thing for well 6. Go to calendar, specify the day, click OK, go to options, status, shut in. And I believe we're done for this section. We're going to press OK. Now we're going to add the injector wells. So we're going to click on wells, right click on wells, select new. We're going to name the well 5 injector. It's going to be injector mob weight, and this is very important. We need to set the definition date to 501 days since the simulation start. And we're going to press OK, and we're going to add a constraint, operate, and we're injecting water, so it's going to be STW, and we're injecting 500 barrels per day. And we're going to add another well. This is going to be well 6 injector. Again, it's going to be injector mob weight. So we're going to select the definition date, which is again 501 days since the simulation start. We're going to press OK, and we're going to go into constraint. Constraint definition, click operate, select stock tank water, and 500 barrels. We're going to press OK. Now, the wells are showing red dots next to it, and that's because it has not been perforated yet. So we're going to perforate it by clicking on the date perf. We're going to go into the perforations tab, and we're going to click on the little icon that says insert before selected node, and we're going to insert the X, Y, and Z coordinate of well 1. So well 1 is located in 49, 56, and 1. We're going to select apply and move on to the next well. And also, we're going to click on insert before selected node, and we're going to type in the X, Y, and Z. We're going to do the same for well 3. So well 3 is a horizontal well, which means we have multiple perforations, and we do this by using colon. So it's ranging from 34 to 36 in the X direction, and then 44 in the Y, and 1 in the Z. and it automatically makes the 3 perforations. Apply. We're going to move into well 4. It ranges from 30 to 32 in the X direction, 27 and 1. Apply. Well 5 is in 15, 11, and 1. Apply. This is well 5 injector, so it's going to be in the same location, and it's probably going to give you a little pop-up saying another well has already been perforated in this chosen block. Do you want to add a new perforation? We're going to click yes. We're going to click apply. We're going to go to well 6, add the X, Y, and Z coordinates, which is 6, 31, and 1. We're going to click apply, and this is the last one. 6, 31, 1. And we're going to click yes and apply and OK. And all the red dots are gone. And the last thing that we have to do is add a range of dates. So we're going to click add a range of dates. We're going to start from 0 days to 1001 days since the simulation start, and press OK. And we're going to adjust this step to 1 day. We're going to press OK, and it says 999 new dates have been added. OK, close. Now we're going to save. We're going to click File, Save, and we're just going to change the name of this, and we're going to save OK. And we can exit out of Builder. Yes. OK. Yes. We're going to now click on the project1.dat file. It's going to open in a text version. And now we're going to add the heterogeneities and make some changes. First thing that we're going to look for is the axis keyword. It is right here, and it says 1, -1, 1, and we want to change it to 1, 1, 1. The next keyword that we're going to be looking for is dtop. Dtop is set to 6,000 times 100, which is basically 80 times 75 times 100, and dtop is varying, which is, so we're going to erase that. We're going to go to the dtop file. We're going to copy this and put it right in here. So the dtop file is basically the grid depth minus 25. In our simulation file, we're defining depth at the grid center, but dtop is located at the top of the grid block, so we needed to subtract half of the grid block thickness. We're going to look for the keyword permi, which is permeability in the I direction. We're going to get rid of con 100, which means constant at 100, which isn't true. And we're going to add the permeability variation by copying and pasting this permeability text file and pasting it onto here. And as you have probably guessed, the next thing that we're going to do is porosity. The keyword for porosity is por, P-O-R, and again, it's set at constant of 0.2, so we're going to get rid of that and add the porosity text file. And the last thing that we're going to do is search for the keyword well 3. So well 3 and 4 are both horizontal wells, so the direction of the well bore is very important. And the direction of the well bore is defined by the keyword geometry. And geometry K means that the well bore is in the Z direction or the K direction, which means it's a vertical well. However, well 3 and 4 are both horizontal wells in the X direction, so we need to change geometry K to geometry I for both well 3 and for well 4. So this is a geometry keyword that goes with well 3. This is the geometry keyword that goes with well 4. So I'm going to also change this to I, which means it's a horizontal well in the X direction. And I'm going to say file and save. And I can close this. And there are two ways you can run the simulation. You can either drag it into Builder, or you can just drag it into IMAX. I prefer to do it in Builder, so I'm going to drag it into Builder. I'm going to click Validate with IMAX, click Yes, and select Run Normal immediately, and press Run. So after it has finished running, you can click on Launch Results. This is equivalent to dragging your project1.irf file into the results 3D. You can also drag this file into results graph, and what it's going to do is plot important parameters in terms of time, so it's a very useful tool. So now this is results 3D, and with this drop-down menu, you can select the parameter you want to look at on this plot. So if you want to look at grid thickness, this is constant, not a very good parameter to choose. If you wanted to look at grid pay depth, it's going to be different. And if you want to change the time at which you're looking at, you can use this bar to go from one time to another. So a good one to look at would probably be pressure. So you can click on pressure and you can look at different times. You can also use the drop-down menu to select the times. If you click on the block, it will tell you the block number and the pressure. If you want to quickly look at multiple parameters at once, you can go to View, Probe Display, Other Spatial Properties Value at the same time, and use Auto Probe, so when you just hover over it, the values will come up. And you can select multiple values by using the Control key and press OK. So let's do this for pressure and saturation. So pressure, and I want to do water saturation. So Control water saturation, click. And we're going to press OK. And when you go back out, you can see that we are seeing both pressure and water saturation show up in the little box. So that's very helpful when you're trying to fill out the PowerPoint. Another thing that I want to show you is project 1 IRF file into results graph and how we can use this. So this is going to create plots of important properties. So if you click on this icon called Add Curves, you can choose a parameter that you would like to plot. So let's say we want to look at oil rate daily standard condition for well 1. It will plot it this way. We can add a new plot by clicking on this. And let's say we want to look at well bottom hole pressure. We can well bottom hole pressure, and we want to look at it for the entire for every well. We can click on Shift, and press OK. And it will plot everything, and you can export it out using the tools. You can click Export directly to Excel or text file if it's easier for you. So that is the end of my tutorial. If you have any questions, feel free to come into my office or email me. So thank you so much.